Hi, I'm Miss Hearn. Let's get started. So step one, when I say solve implicitly for dy dx, that just means take the derivative of both sides and get dy dx by itself if you can. You should be able to. Okay, so in this case, the derivative of y to the 7th, notice that we're differentiating with respect to x. I know this because it said to find the second derivative with respect to x. So that's why I took the derivative with respect to x of both sides. Now the derivative with respect to x of y to the 7th, we just use our power rule, 7y to the 6th dy dx. Make sure that you put that dy dx there. Yes. How the chain rule works with it. What makes it work that way? Well, let's think of a different problem. What if we had the derivative of 2x minus 1, for example, to the 7th power, right? So what does the chain rule tell us to do? Take the number out, the power out front, leave the inside function the same, right? Subtract 1 from the exponent, and then multiply by the derivative of whatever was in the parentheses, right? Okay, because that wasn't an x, we have to compensate. And so we get a 2 here. All right, we're doing the same thing. 2x minus 1 is just a nickname for some number, some unknown value, right? So instead I have a y, also just a name for an unknown value. I'm differentiating, so I bring the power out front, I subtract 1 from it, leaving the base the same, the inside function the same. Then I multiply times the derivative of the inside function. But of course, in this case, all we can say is that's dy dx. So that's how I get the left side here. Okay? Okay, on the right, we're differentiating a function of x, so we just say 9x to the 8th. And then I isolate dy dx. So dy dx, the derivative is 9x to the 8th over y to the 6th. All right, step 2. We want the second derivative. So I am once again going to take the derivative with respect to x. But when I do that, on the left, take the derivative, I get second derivative. On the right, I have to use a quotient rule, right? Because I have something with a variable divided by something with a variable. Notice that when I take the derivative of the bottom right here, we're taking the derivative of y with respect to x, that you get a dy dx in your expression, right? So you can replace dy dx with what it's actually equal to. Yes. Notice that when we're doing the quotient rule, we have top over bottom. When we take the derivative of the bottom, you get a dy dx, which means that in your formula for the second derivative, you have a dy dx, which we don't want. But that's okay. That's why we have, in step 4, it says replace it with that. Okay, step 3, isolate the second derivative. We've already got it isolated, so that's done for us. But step 4, we're going to actually replace dy dx with 9x to the 8th over 7y to the 6th. So that's something weird that happens when you're finding a second derivative implicitly. Okay, and then the other thing is, now we simplify. Step 5, when we simplify, I got 486x to the 16th y to the negative 1, or you could think of that as over y. But regardless, you got to clear this y to the negative 1 here. And the way that I did that was to multiply both terms through by y. You have to multiply all the way through, top and bottom, by y. And now what you get is this weird, see this 504 x to the 7th, y to the 7th, 486 x to the 16th. There's nothing wrong with that. But in this particular case, our original function or relation, I think that actually is a function. Our original function gave us a relationship that said that y to the 7th is actually equal to x to the 9th. So in order to get the answer to look like the answer in WebAssign, you have to use that. So if you look right here, notice that y to the 7th is in the numerator there, and that if we replace it with x to the 9th, what do we get? What's x to the 7th times x to the 9th? X to the 16th, which would make these two like terms. You see that? And then you can actually subtract. So you get 18x to the 16th, 49y to the 13th. Now, I'm not going to waste your time with all of that on the test, okay? I'm just telling you why in WebAssign the answer looks like so different from what you probably got, because they went back and they used this. In fact, what they got was 18y over 49x squared. And so I had to work a little bit to get from my answer to see that it was the same. But in fact, it is the same using the fact that y to the 7th equals x to the 9th. I hope you found this video useful. If you did, please remember to like it.